Hello everyone. Welcome to the second webinar of a series of Voortman webinars scheduled this year. Great to see so many of you joining. Today we're going to turn you into real plasma bevel cutting pros. Voortman Steel Machinery and Hypertherm Associates are collaborating once again to share their collective knowledge so you can create high quality bevel cuts and weld preparations. Whether you're a beginner or a seasoned expert, we will arm you with an array of tips and tricks to take your bevel cutting skills to the next level. Whether you work with plates, pipes, domes, profiles, we got you covered. So, what can you further expect in this 60-minute session? You will get insider tips on optimizing bevel cutting, perfecting height control, and achieving the optimal long bevel cuts. Furthermore, you will learn how to manage situations with warped plates, interrupted cuts, egg-shaped pipes, and deck maintenance, and much more, all while keeping costs in check. Please post your questions in our live chat, and our chat team is available to answer any queries you may have. Some of these questions will be answered by our speakers at the end of this webinar, so feel free to ask anything that sparks your curiosity. My name is Olga Jurjens, and I'm the moderator of today's webinar. Joining me is an esteemed panel of industry professionals, and it's an impressive lineup, so get ready for a dynamic and diverse discussion. To my left is Stef Rohan, Product Manager Plate Processing at Voortman. To my right is Joey Scheur, Business Unit Manager also from Voortman and also for the plate processing machines. And just like last year, we have Timo Legger, Consumable Sales Manager of Hypertherm Associates. During the webinar, we will switch to our live production location, where Sean Wildhagen, Application Engineer of Hypertherm Associates, will join the session as well. He will, together with Joey, explain different bevel techniques and scenarios by means of a live demonstration. For those not yet familiar with both companies, let's give a short introduction. We've gathered here within Voortman in the Netherlands, where inspiration meets innovation. And we're sitting here in the Experience Center, which is part of the large Voortman campus. As you can see in the video right now, we've recently built a very large Voortman Engineering Center, which is a stunning space for all the brilliant engineers who work on top-notch software solutions and mechanical solutions. Joey, can you shortly introduce Voortman?
Yes, so for those in the audience that don't know Voortman yet, Voortman is a supplier of CNC steel processing machinery, and we have quite a wide range of processes in our portfolio. So we create sawing machines, but also shot blasting, painting, drilling, milling, but of course also thermal cutting. Especially on that technology we're going to focus today, and then on the creation of weld preparations. Now with thermal cutting you can do a lot of different 3D applications, so we can also create countersunk holes. But the topic today is about weld preparation creation. If you look at the world, there's quite a scarcity of welders. And of course the creation of weld preparation is already designed to reduce welding hours. But creating a high quality weld preparation allows for, or at least make sure that you have less grinding at the welding spot, but also allows for more automation in the welding process. We serve quite a variety of markets, so not only steel fabrication, but also steel processing, the processing equipment market, offshore and energy. What you see in those markets is quite a wide variety of bevel types and kind of parts, so some are more complex than others. Some bevels are also more complex than others, but you will see that through this webinar we have such a wide array of tips and tricks that I think all industries will benefit.
Yeah, today's topic should pique the interest of a wide-ranging audience. Timo, can you introduce Hypertherm?
Sure, absolutely. For over 55 years, Hypertherm Associate has been providing customers with the industrial cutting solution they need to get the job done right on time and on budget. From aerospace to agriculture, offshore and energy to steel fabrication, our brands and technologies, including plasma, water jet, consumable and software, can be found performing advanced manufacturing around the globe. So Voortman integrates our Hypertherm plasma systems for heavy industrial solutions like XPR and HPR into their total machine solution. Additionally, we offer light industrial like power sources such as power mugs. So for today's webinar, we will focus on how we can help companies achieve greater automation, efficiency and profitability with heavy industrial systems and technologies like true Bevel. So to conclude, we are headquartered in the US with operations and partner representation worldwide.
Yeah, thank you, Timo. In terms of solutions and achieving impeccable bevel cutting quality, Hypertherm and Voortman complement each other very well. And what's a better way to demonstrate this by means of a real customer video from a customer all the way from Germany, which is Karl Hartinger. And Hartinger is a family business which offers comprehensive crane services to the private and industrial sectors since 1952. And they benefit from best of both worlds since they invested in the Voortman V310 plate drilling and cutting machine, which is equipped with the Hypertherm XPR 300 plasma source. Let's have a look.
Also wir haben im Vorfeld auch schon mit einer Hypertherm-Stromquelle zusammengearbeitet, nur ist die Hypertherm XPR 300 natürlich nochmal eine deutliche Steigerung im Vergleich zum Vorgängermodell. Wir finden, dass die Verschleißteile deutlich vereinfacht sind und auch die Standzeit der Verschleißteile nochmal deutlich optimiert worden ist. Also die Schnittqualität ist deutlich besser als bei der vorherigen Maschine und man merkt auch sofort, dass die Wahlkampfsoftware auf die Hypertherm-Stromquelle angepasst ist. Dort müssen nicht großartig Parameter eingestellt werden, man wählt sein Blech aus, seine Blechstärke und kann direkt starten. Also in wenigen Arbeitsschritten wird eine sehr optimale Schnittqualität erreicht.
Ja, der typische Ablauf der Maschine ist das Programm draufladen, einmal abfahren lassen im Trockenlaufmodus. Wenn alles okay ist, Start drücken, ja, und dann warten, bis fertig wird. Hier, das ist so ein Teil, was wir mit der Maschine gefertigt haben. Das hat eine Außenphase auf der Seite, dann hier noch eine Phase, eine kleine, hier eine Innenphase, plus die Flächen hier sind nochmal gefräst und plus halt Gewinde. Und das alles in einem, ja, mit einem Mal auflegen.
As I mentioned earlier, we did a joint webinar last year, and during the span of a year some quite remarkable and exciting developments can happen within a company. And at Voortman, one of the most recent ones is the acquisition of German pipe processing machine manufacturer Müller Opladen. And Joey, what does this acquisition mean for Voortman?
Yeah, so like you said, indeed, Müller Opladen is a producer of CNC steel pipe processing machinery. And they are quite a well-known brand in the pipe processing market. So they are active in more than 70 countries. They have also served more than 1,000 customers, which is quite impressive. And the actual strategy behind this acquisition is that, of course, we have widened our portfolio, so we can now offer also a wide range of pipe processing solutions to our end customers. But it also allows us to go into other markets more deeper, such as the offshore market, the offshore energy, but also the processing equipment.
Yeah, a great development for the future growth of the company. Before we get started, we are curious on your viewpoint on creating high quality bevel cuts and weld preparations. And right now a poll appears on your screen asking you, what is your current experience in creating high quality weld preps and bevel cuts? Are you currently manually creating it? Are you already automating the process? Don't you have any experience at all? Or are you considering automating the process but don't you have the knowledge or machines with bevel cutting capabilities? Please select the option that best matches your current experience. So today we're going to focus on the 3 crucial elements influencing bevel cut quality, which are cutting height, cutting angle and cutting curve. And before we dive deeper into those factors and deeper into the technology, maybe it's good to first give a little bit more context about the different bevel types that one can create, Steph.
Yeah, indeed, that's a good idea. So I think what's important to note is we have 6 different bevel types which you can distinguish, and they are all representing a letter, and that's the way you can recognize a bevel type. So as you can see on the screen in the image is that we have the 6 bevel types, and first we can explain the free bevel, which you can see in the left top. It's also called the bottom knife because the bottom of the cut is the sharp part. Then we have the A bevel, which is basically upside down of the V bevel, which is also called the top knife because the top is the sharp part. And those bevels exist of one cut, but we have also the multi-cut bevels, like the Y and the Y upside down bevel, which you can see in the right top. And as you can see, those bevel types also have a straight edge up front, and a straight edge can help you with fitting the plates on the weldment, but it will also reduce plate warping during welding. And then in the bottom we can see the X and the K bevel types. The X and the K bevel types can be used for a thicker plate, because then you want to apply small welds on both sides of the plate to reduce the plate warping. But of course in some occasions you maybe cannot reach both sides of the plates, so then you will still use the Y bevel to make sure that you have that straight edge and that you can apply a weld preparation for the welding. And I think it's good to mention that the straight edge, as I'm talking about, we call it the nose of a bevel. So we will also use that term in this webinar. So the straight edge is the nose of a bevel.
Yeah. Okay, now you know that which different bevel types can be created. Let's kick things off with the first main element influencing bevel cutting quality, which is the cutting height. Joey, can you provide a little background on this aspect first?
Yeah, so the height, the cutting height, by far is the most crucial element within bevel cutting. And if we talk about cutting height, we speak about a two-phase process. The first phase is the height sensing, and the height sensing is used to define where the material initially is. The second phase is the height following. One can imagine that a pipe is never perfectly round, a plate is never perfectly leveled, and the flanges of a beam are also never perpendicular exactly to the web. So even if you have found the material, you want to follow that profile of the material itself. Now, let's first focus on the height sensing, because it's quite important to understand how we can accurately achieve make an accurate height sense method. Now, if we look at programming, what is important is that with cutting, like Steph already mentioned, with a K bevel you got multiple cuts. Now, with multiple cuts you often got pierces in close proximity to other pierces as well. And this is quite typical with plate processing, because there you got a lot of bevels in close proximity of each other. What is important is that those pierces do not affect future height sensing methods. So what we as Voortman already do is that we try to move the height sensing method towards the product itself, then move back to the piercing point, and then start cutting. By doing this, we already try to create a distance between piercing points and between the height sensing point. But of course, not all customers have current Voortman machines. Some have other equipment as well. Now, what we would advise in those kind of with those kind of machines is that they vary the lead-in lengths of different cuts. So imagine if you make a K bevel, then the first cut could have a shorter lead-in than the other lead-in of the top bevel, of the top cut, and by that you ensure that the height sense is also a bit moved away from the piercing point.
Yeah.
Yeah, and I think, Joe, it's also good to mention that we as Voortman try to add functionality to reduce the impact of slack on the height sensing. So, for example, a couple of years ago we introduced the dross inhibitor, and what the dross inhibitor basically does is that it sprays a layer of oil on the plate just before piercing. So the slag and the will not accumulate on the plate like a big puddle, but it will bounce off. So then we have less slag around the piercing points, for example, for multiple cut bevels. So this is really good for a plate cutting machine, because when you have small products and indeed the multiple cut bevels, you have a lot of piercing points in close proximity of each other, as you explained. So then the dross inhibitor is really helping to reduce the amount of slag on the plate at the piercing points.
And improve bevel quality.
Yeah, indeed.
But not everybody, of course, has Voortman machines. So I think it's also, especially in those cases that people have other equipment and don't have that dross inhibitor, you also have other strategies. What for instance one could do is that one pre-pierces or pre-drills the entire plate first, and then removes the slag and then executes the cutting. Now, by doing this, you prevent that slag impacts height sensing methods. Now, not everybody wants to do pre-piercing, of course, because it takes time. Pre-drilling as well. With pre-drilling, one advantage additionally is that no slag at all is created. And I think what is important is because the audience is already thinking that indeed it takes a lot of time, it takes a lot of money to pre-pierce the entire plate or pre-drill the entire plate. Now, we as foremen allow pre-drilling also to be done unmanned during nighttime or unsupervised. We use a so-called unmanned mode, where you turn the machine in an unmanned mode and the machine can drill several plates on the bed and just try to work around manual actions. Now, you do the pre-drilling then at night and then start the bevel cutting during the daytime.
Yeah, very efficient.
Yeah. So even in situation where high sensing methods are employed near areas where slag has built up and the previous mentioned strategy haven't been implemented, so the operator still plays a crucial role. So by closing monitoring the process, they can ensure that slag around previous pierce point is removed to prevent any potential impact on the future cut. So, but also that slags is removed when it attached to the shield in a timely manner, because this also impacts the high measurement.
Okay.
Yeah, from what I just heard, there are a variety of ways to reduce the variation in height sensing when it comes to programming, operating the machines, but also some new technologies that became prominent the last couple of years. However, what I hear from your discussion is that you mainly speak about height sensing before cutting. But Joey, how can you effectively maintain the desired height when you have to deal with warped plates or movements?
Yeah, so indeed, Olga, and like I said, you have two phases. Now, the second phase is height following. Now, if the plate is not leveled, then again the tube is never round, so you've got egg-shaped tubes quite often. Then we also try to follow that surface of the material itself. And we try to do that with various methods, but let's just first focus on plate processing. What is important, and that's actually the case with all kinds of profiles, is that you want to keep the nozzle at exactly the same distance from the material, because the arc shape is defined by when it exits the nozzle. That's where that's what is important. However, what we do with plate processing is we try to follow the height based on the plasma arc length. Now, the plasma arc length is measured based on the electrode towards the material. What's important now is that the electrode wears down, and then the arc becomes longer, and then normally the nozzle would go a bit more to the material, impacting your cut quality. So what we do within our plate processing systems is that we try to take a sample with each cut of what the impact of the consumable wear is on the arc voltage, and then we correct for that.
Yeah.
The plasma arc we follow over the cut, so when the plate goes up, the arc gets shorter and we send the torch upwards again. And so with that method we try to follow the surface of the material itself.
Yeah.
What is important is that for this method to work, the programming order of the bevel should also be done in a specific manner. So if we look at, we made a video of that to explain a bit of how we should look at that. Imagine if we have an X bevel. Steph already explained that if we have an X bevel, it's a multi-sided cut. Normally you always want to make sure that you cut from top to bottom or towards your part. And we explain that by trying to do it in a different manner. So imagine if we have an X bevel and we try to cut the top first of the X bevel and then cut the bottom. If we cut the top first, what can happen is that the waste material can move compared to the part. Now it can move upwards or it can move downwards, it doesn't really matter. But imagine if the waste would have moved downwards compared to the part. Because you could have imagined there's a curve, cutting curve between the waste and between the part. So there's space to move. Now if the material then moves and we try to follow the height of the second cut, so the bottom one, you can see that we follow the height based on the level of the waste material. Now, and that influences then the bevel accuracy.
Yeah.
So the programming order is really relevant. You always should work from bottom to top. Now, and to finalize this, of course in CAM packages normally this all goes automatically, so customers normally should not worry. But especially if you program parts manually in CAM packages, then it's really important to understand that you should work from bottom to the top.
Okay, so really something that shouldn't be underestimated by the users.
Yes, indeed. You should not be underestimated.
Okay.
Yeah, during customer visits, we often see that torch high control is not even set up in the correct way, right? So if the calibration of the arc compared to the high isn't set properly, and this could influence in the part dimension as well. So one way to measure this is cutting a straight line with a fixed speed and high and measure the real arc voltage on the CNC. So Voortman, for example, CNC has the capability to use the true volt, which will eliminate the need to calibrate the torch high control as it is done automatically. So with true bevel incorporation, the correct parameters include the torch to work distance are automatically included, making it easy to get accurate bevel cuts, and set up new jobs can be done very quickly.
Yeah, we show a lot of beveling, and this reminds me of the fact that we get a lot of questions from customers about the different bevel designs that exist in the market and the advantages of those bevel designs.
Yeah.
And Timo, so as someone who encounters different machine brands and different bevel designs, can you shed some light on the different bevel types?
Yeah, it's a great topic, and I will do my best to simplify it as much as possible. You could distinguish two types of bevel units. So one is so-called torch center point bevel units, where the machine are created in a way that when the bevel axes are used, the unit rotates around the physical tool center point. So these bevels are called AC bevel units because, as already mentioned, they use two axes, A and C, mainly to set the bevel in the right direction and under the right angle. So the other unit that we see in the market, and that's all the one I saw on Voortman's plate machines, is so-called non-tool center point units, or sometimes also called ABXYZ. So this type of bevel unit does not specifically rotate around the tool center point. The bevel unit utilizes all 5 axes to adjust itself to specific cutting height and the direction and the cutting angle as well.
Yeah, indeed, and I think it's good to mention, Timo, that now with the acquisition of Müller Opladen, we have both bevel designs within our portfolio. So when we look to the plate processing machines, we use the non-tool center point bevel. So as you explained, you need all axes to position the torch in the right way. So the machine should be really dynamic. And we are using the helical rack and pinion gears on our moving gantry machines, and also linear guides to make sure that the machine is really dynamic and accurate, to make sure that we can produce nice bevels with that non-TCP bevel system. But what the nice thing is with that non-TCP is that we are really flexible with variable bevel angles and distances. So we can really reduce and optimize the torch to work distance with this type of bevel design. And yeah, as you know, when we can shorten the arc, and when we can make the optimal length for the arc, then we will reduce stress on the electrode, and in the end it will reduce consumable wear. So that's a good thing. But when we look to the pipe processing machines, we use the tool center point bevel design, and it is combined with a mechanical height sensing unit. And it's nice to use such kind of bevel on a pipe cutting machine, because sometimes you have to cut bevels of maybe 60 or even 70 degrees. And with plasma you're limited by the torch design, so you cannot create those kind of bevels, so we need the Oxy-fuel process. But with the Oxy-fuel process we cannot actively monitor the arc to maintain the right height, so we need the mechanical height device. So we can easily transform that type of bevel unit into an Oxy-fuel bevel unit. So that's a nice thing about the tool center point bevels on the pipe processing machines. And what is also good to mention, I think, is that we have a separate torch axis on the tool center point bevel on the pipe processing machines. So we can basically eliminate the disadvantage of the tool center point bevel, because as you can see in the video, we can move the torch axis to also reduce the torch to work distance, and therefore reduce the consumable wear. But also when you have bigger pipes and you have a welding seam where the pipe is connected and welded together, then normally when the height sense will run over that seam, the set axis will be retracted, and then you will have a different nose. It will not maintain the same height. But what we do, we only retract the torch a bit to make sure that it is not colliding with the pipe, and then you will not have a different nose height, but the nose height will stay equal all the time. So we will have a high quality weld preparation on pipes.
Yeah, I think you clarified the two different bevel types quite well. What we frequently observe with K-bevels is that small pieces of material can be cut loose and might interfere with the torch cutting pad and interrupt the cut. And we see really customers struggling with this. And in such cases, they either must finish the cut manually, or if they can manage to finish it on the machine, they have a significant amount of rework afterwards. So that's why we investigated and put quite some time at Voortman to develop a nice feature functionality for this, to resume this bevel cut and improve the quality. And that's why we recorded a nice video this week with Joey to see how this resume cut functionality works in practice. Let's have a look.
Sometimes it can happen that the cut stops. Perhaps because of the end of life of consumables or because of heavy plate warpage. Now, for this specific purpose, that the cut is interrupted, Voortman has developed the resume cut feature. That is a feature where we can easily restart or resume a cut that has been interrupted. We click the operation and we click resume. And now we see that the status has been changed of the operation. If we now press the start button, the torch will automatically move to the position of the error. We see that we have an arc lead-in, and that arc lead-in is made to minimize that damage on the part again. And we click finish.
Okay, let's talk about variable bevels. Although variable bevels may not be as commonly encountered within plate processing, they are quite significant seen in pipe processing. Given that pipes are inherently non-perfectly round, how to deal with it when it comes to finding the perfect cutting height, Joey?
Yeah, that is a good question. So we already talked about that we try to measure with arc voltage, but the arc, of course, depends on the bevel angle, depends on the thickness you are cutting. So if you have a variable bevel, and I think we have a video of that, for instance, when we cut a mitre, if we have a variable bevel and you cut on the top side, for instance, you cut a bottom knife, so it's a V bevel like Steph explained. But then when the pipe rotates, it rotates 90 degrees, you're moving to a straight cut, and then in the bottom, you move to a negative 45 degree bevel to cut a mitre, only to cut a mitre on a tube. Mm-hmm. Now, the arc changes, so normally if you just try to steer based on the arc length, then the torch would just try to move towards the material and then further away from the material, so that doesn't work. Now, what we try to do is we try to use the true bevel technology of Hypertherm, and then what we try to do is if we move from a 45 degree bevel to a straight cut, we know exactly based on a true bevel chart, we know what the impact is on the arc voltage. We still take a sample in the beginning of the arc voltage, but if we move to 0 degrees and back to 45, we know, okay, it's for instance +7 with the arc voltage. So we try to use a prediction model to keep the nozzle exactly at the right distance from the pipe. So we still use arc voltage, it's kind of an extension of what we're using within plate, but we also try to predict the impact of changing the bevel, what the impact would be on the arc length. And with that still try to maintain the right nozzle to material distance.
Yeah.
I see that on the pipe cutting, you try to maintain the right height by controlling the arc. So, but we see all the various methods in the market to achieving the same goal. For instance, a different approach in maintaining the right height is to probe the material at several spots along the cut. Instead of adjusting the height while cutting, the torch cutting path is defined upfront by measuring the entire tube. So, what we also see is that some use a separate mechanical device or a laser measurement that follow the deviation of tube, and with that controls the height of the cut to ensure reliable weld prep creation.
Yeah, that's right, Timo, because we also indeed have the laser sensor to scan a pipe, or most of the times we use the example for a dome, to scan it up front and to measure it up front, because we know the material is not going to move. So then we can do that upfront measurement. But also in cases with plate, for example, when we are cutting plates can start to warp, or maybe they come loose, and then the height of the plate will differ. And then we need an active and dynamic height measurement, as Joey already explained before. So then we can do not do the measurement up front, but we will just measure the plate during cutting and correct it for the right height.
Yeah.
Okay, having covered the importance of maintaining the correct cutting height, let's shift our focus to the other element influencing bevel cut quality, which is finding the correct cutting angle. Timo, can you first provide a little background before we move on to the tips and tricks?
Yeah, sure. So the plasma arc is never perfectly straight, or it has a slight taper or oval shape. So due to this oval shape and the taper, a certain compensation is necessary to achieve the desired dimension for your bevel. So, and you want this compensation to be thickness, angle and bevel type dependent. So by bevel dependent we mean that a Y bevel differs from a X bevel, for example. So but Hypertherm through bevel technology provides a compensation chart that consider all the variables mentioned before. That means in the earlier stages of beveling with plasma cutting, for example, the typical manual adjustments like a try and error were frequently made at the machine. So operators would receive a nest with multiple test products nested within it. So these test products were cut and the program was then readjusted with the appropriate bevel compensation to ensure smooth operations throughout the entire nest. So with the true bevel technology integrates in the machine, most of these testing runs belong to the past. But nevertheless, in case where the bevel shape is unusual, or when, let's say, consumables are considerably worn down, it is still possible to adjust these compensation by yourself.
Yeah, thank you, Timo, for sharing your additional observations based on your field experience. Now let's take a closer look how this process unfolds in a real production setting, and that's why we switch to our live production location, where Joey and John are standing at the machine right now and are ready to guide you through the process step by step.
Okay, thanks Olga. As Olga already mentioned in the beginning of the webinar, actually bevel cutting is mainly used for welding preparations, right? And what we hear often from customers is that welding preparations, the beveling is very complex to keep the right dimensions, for example. You know, you create an angle, how do I get the correct angle on the part? When I have the correct angle, are actually the dimensions correct? And if I have this correct, how can I now produce 100 times the same part? So really in the life of an entire plate, can I produce each single time the same parts? Now, because it's pretty complex to get this, you need actually some skilled operators to do this, right? To really know what they are doing, adjusting some angles, adjusting some parameters and things like that. So that's why we also often see when we get at a customer, they use the Oxy-fuel burners. The track burners or the mechanical device to make these welding preparations. So they have different stations, maybe 1 or maybe 5 of these stations. So what they actually do, they cut the standard straight cut on the part, they take it off the table, and then from the table they put it on a pallet. From the pallet they move the pallet to another station, and in that station some operator of the track burner picks it up, put it on the table, needs to adjust for the correct bevel, and then when that's done he cut the parts, put it back on the table, and then somebody moves it out there. Now this is of course very time consuming. You have moving parts back and forward through the factory, which could be potentially a safety risk as well. Parts could drop on somebody's toes, things like that, because they have to lift it. But also you start using combustible gases on the Oxy-fuel torches where you run the torches and things like that. So that's where actually Hypertherm thought, okay, let's create a true bevel, make life easier for an operator, right? So that you punch in the numbers and actually say, I want to have this bevel, this and with this dimension, and for the operator to press the button and then you get the correct part out. So you will be getting more accurate, you get more of the similar parts during the whole plate cutting. So really make an operator's life easy. That's basically why we have true bevel and put also in the controller to work with us. So that's the case.
Yeah, we have an example, John. We have an example that is exactly explaining what you're just telling us. So that's understating what you're just telling us. We had a customer that was currently running all kinds of straight parts just on a machine, bringing them to a separate station. They had several stations with indeed Oxy-fuel track burners, and then beveling those parts afterwards. What they now did was they invested in a new machine that could do beveling directly on a spot like this, made completely ready parts, and that then when finished and went to the welding department. Yeah. By doing it directly on the machine, they increased output by 100%. And I must say, of course, they had complex parts, they had multi-sided bevels, so K bevels, X bevels, but you could see that if beveling is made easier and consistent on the machine, that it can really increase your throughput to your shop.
Yes, yeah, your output will be massively increased, like you said.
Yeah. And now you're telling about true bevel, but let's see how true bevel works in practice. So we just cut a part. This is the part. Now normally, of course, with true beveling, like Timo already mentioned, cutting a lot of samples should not be necessary. But let's say that the bevel is still off. So we have a bevel here. The nose should have been 4 millimeters. Let's measure it up. It's roughly 5.1, 5 millimeters. Let's now correct this in the software and see how easy that is. Here we have the operation list. We open up the operation where the bevel was in and we go to more details. Now we see the entire cut operation, but we want to adjust the specific bevel. So we move through the cut operation and then we see the operation being changed to a bevel record. From this point we can open up directly the records that has been used for this bevel operation and we can adjust it here on the spot. So imagine the nose here, we measured it up, it was 5 millimeters. We want it to be 4. So we have to reduce the curve to make sure that the cut goes deeper within the part and the nose is reduced. What's important is that now we want to shift it by 1 millimeter in vertical direction. What's important is that the curve is always perpendicular to the cut surface. So we have to adjust it a bit more to make sure that we go down by 1 millimeter. So we reduce it, we save it again. The machine will ask us now to regenerate the cycle list. We state yes, and let's cut it again.
So while Joey is cutting, I would like to explain a little bit about the bevel and the 45-degree bevel weld preparation. Actually, to get a 45-degree bevel, we need to adjust the torch, right? We need to compensate the torch a little bit to really get to the 45 degrees. Now, in this case, what Joey did is actually he put in a compensation of 0.64 to get to the accurate 45-degree bevel. Now, what we did with the XPR torch, this is actually the XPR torch, they have a more pointy consumables. So the shield is a lot more pointier than compared to other systems. So with this torch we can actually go to 52 degrees of an angle. That means with the compensation we actually can go to 45-degree cut angle, right? So a real nice top and bottom cut of 45 degrees. Where this is also very useful is actually when you start cutting, for example, domes, or you start cutting tubes and pipes. That's where if you start cutting those kind of things, then the pointed consumables are very useful as well. Now, if you would cut pipe, for example, and you have a connection point with a pipe, and you would have another pipe already in a 30-degree angle, of course, if you have 30 degrees, you want to have 45 degrees, you cannot go all the way down, right? So you are limited to the torch of 55 degrees of an angle. But the pointed consumables give you a lot more flexibility, more accuracy on actually the whole bevel cut. So, Joey, back to you.
So we've been cutting the part. Let's measure it up if it's correct now. We've already adjusted the curve. Let's see. The nose had to be 4 millimeters. So let's measure it up and see if it's actually 4. I would say perfect. A perfect 4 millimeters. Now back to you guys.
Steph, are there any other factors that users can directly control for finding and maintaining the correct cutting angle?
Yeah, I think there is, because now we are mainly talking about the machine and the torch, etc., and how it's tilted. But I think it's also important to mention the cutting deck. The cutting deck is also really important to make sure that the plate is leveled and that the plate is aligned with the torch. So, for example, when you are cutting straight cuts, it will not really make a difference if the plate is not really leveled. It will only make small deviations. But with bevel cutting, when the plate is not leveled, you will see that the nose will not have the right height, but that it can vary, and also the angle of the cut can vary. So that can be quite a big problem. And yeah, one of the main reasons, of course, for a plate to be unleveled is the cutting deck. So it's really important to maintain your cutting deck to ensure proper quality of your weld preparations. So yeah, that should also not be underestimated.
No, indeed. Yeah, one can also reduce tilting issues by implementing different programming strategies, and that's why we get back to our production setting, where Joey and John are showing you different programming strategies and their influence on bevel cut quality.
We have already stated several times that programming is quite relevant for maintaining bevel accuracy. What we often see at customers is that their deck is not well maintained, and then they cut parts, long parts, with beveled edges somewhere at the outer side of a part. An example like this. So here we have a part, and imagine that it can be significantly longer than this. Here we cut first the straight edge alongside the edges here, and now after that straight edge, the part has room to bend in this direction. After that, the beveled edge is made here, but that bending effect can influence the quality of your beveled part on that side of the cut. What we would advise in that case is first focus on the bevel side of your product, cut the straight lines there, cut the beveled edges there, and then cut the rest of your part. If you do it in that way, then locally where you make your bevel, the part has no room to bend because it's still fixated to the rest of the plate and still leveled, and then afterwards you cut the straight edges. What we also often see is that customers struggle with longer bevels over longer lengths. So imagine 3 meters, 6 meters or even 12 meters long. They are not able to maintain accuracy over the entire length of the plate. What's important there is of course deck maintenance. So you have to make sure that your deck is quite well leveled. And you have to make sure, of course, that your part is not influenced that much by heat or warping. If that is the case, so if you can't make sure that your deck is well maintained or well leveled, and if you can't make sure that heat doesn't affect your part, then what we would advise is to stitch your part, make sure that your part is still connected to the rest of the plate. So the part itself stays in shape and the part itself doesn't warp because it's fixated to the rest of the sheet. We will now cut a part over a longer length and show you guys how we are able to maintain accuracy and what you can expect of a bevel over a longer length with using the right programming strategies and using the right type of maintenance.
Because we are beveling a longer part at our production location, and this will take several minutes, we will see the results later. Timo, there has also been a considerable debate about using stitches and its role in maintaining bevel accuracy. I'm curious about your thoughts on this matter.
Yes, for sure. I think stitching, or we call it tabs, help especially in case of plate warping. But one thing I want to also add is that stitching not only offers advantages in terms of preventing part tilting, but also offers benefits when parts have bevels on all edges. So when a part has multiple cut bevels such as Y, X or K bevels on all sides, a stitch is required to ensure the part doesn't drop in the table after the first cut has been made. So in kinds of alliance with what was already said, and that was for maintaining the correct height, the product is used as a reference. If the product drops and the height of the product becomes unpredictable, no height can be maintained anymore.
Yes, having explored the importance of cutting height and cutting angle, it's time to explore the final crucial element for bevel cut quality, which is cutting curve. Timo, I turn it again to you. Can you explain a bit more about it?
Yes, for sure. A curve is an output of the process and not something that can be preset by an operator. So however, precise input in the database is important to get the quality bevel cut. That's all. The cutting curve varies dependent on the type of the bevel, such as a bevel or a V bevel or XK or Y top bevel, how it's called, and the cutting angle and thicknesses. So Hypertherm True Bevel technology is equipped in the system enables precise control over the different cutting curves. So when transitioning from one bevel type to another, the cutting curve are automatically adjusted, typically within a corner loop. So this ensures seamless and accurate transition between different bevel types during the cutting process.
Yeah, indeed, but not always beveling with corner loops is typical, because when we look to the V320 and the V325, which we also sell, those are pass-through machines, and with a pass-through machine the material will move back and forth. And when you use corner loops in that occasion, it could be, for instance with thicker plate, it is the worst problem. When it will fall into the machine but not completely fall away, it can cause a collision between the material moving back and forth and the system itself. So in those kind of occasions, it could be interesting to do beveling without corner loops. It also will reduce the scrap rate, because as you know, the corner loops are taking a lot of material, and
Yes.
you cannot nest the products really close to each other. But then we will advise to make multiple pierces and do restarts to create a bevel cut, just to make sure that you have no collisions between the material and the machine.
Yes, totally agree.
Steph, you mentioned pass-through systems, but for those of you who are unfamiliar with the pass-through systems, we have a nice video of our customer from the USA of HME, who is experiencing working with the V325 plate drilling, milling and cutting machine, and which is equipped with bevel functionality.
So the V325 has been a great addition to the rest of our equipment. We can process up to 4-inch plate, 120 inches wide, 240 inches long. Drilling, obviously, it'll countersink, tap, and probably the most beneficial feature we've seen so far is the bevel head that it has. We have the automated end feed with the lift and carries, as well as a conveyor system for the small part. So after the part is cut, it drops onto the conveyor system, and it conveys it out while the machine continues to process the rest of the material. Voortman works very well with us. They're able to help keep the machine updated with the most recent updates, keep the software fresh, and keep the machine running very well.
Steph, it has come to our attention that there is a growing trend among companies who work with bevel cutting to move away from using corner loops. Can you share some initiatives or developments that Voortman is taking in response to this shift?
I can. So we jointly developed with our nesting partner the functionality of beveling without corner loops. So it is quite complex, and I think it's two-folded. So first, we cannot just cut from edge to edge, but when we are beveling without corner loops, we have to pre-tilt the torch during cutting a straight edge or another bevel. So as you can see in the video, the torch will start tilting before reaching the next cut, and then we'll continue the cut while producing a bevel. But when we are changing the tilt of the torch during cutting, the thickness of the material basically changes, and also the cutting curve needs to be adjusted. So it becomes more of a 3D cutting approach. So we need some complex software for that, but we were able to create it, so we can now support beveling without corner loops. I say now, but later this year it will become available within an update, and then you can have some great cost savings, because you have some time saving, as you can also see in the video, but mainly as I also discussed with Timo, you will have less scrap because you are able to nest your products closer to each other.
Yeah, indeed. Okay, while we were talking, our production site was preparing the longer bevel and to see how accuracy can be maintained. Let's see if the advice they gave at the beginning shows on the actual results.
We have just cut a 6-meter bevel, and we could measure the nose on several spots. We could see that we have some deviations in the nose. So the nose should have been a 2-millimeter nose, and if we measure it up, we can measure roughly 2.5 to 3 millimeters, up to, on the smaller spots here, it slightly goes down to 1.5 millimeters. So you got a bit of deviation in that nose, and that is due to plate warping and due to bending of the part. And that's because the plate, when making the straight cut, the plate is not attached to anymore towards the rest of the product. What we can also do is a different programming strategy. And with that programming strategy, we keep the product itself, we keep it connected to the plate to maintain a higher nose accuracy. We're keeping those noses, so during the straight cut, we keep the part still attached to the plate. And then while bevel cutting, we cut it loose. But because of those connections here, we maintain a higher nose accuracy, because we can see here, it's still roughly 2 millimeters, 2.2, 2.5 maximum. We maintain a higher accuracy because the plate is not able to bend and to warp. So longer bevels on longer lengths are possible, also accurately, but if you do not maintain your deck good enough and your plate has a lot of room to bend or to warp, we would always advise to keep those stitches on spots so the part is connected to the plate itself.
Yeah, thank you guys. We spoke about all kind of software features, the 3 crucial elements influencing bevel cut quality, very hands-on tips and tricks for the audience. But maybe we have some other topics in mind that might be relevant for the viewers. Steph, do you have something in mind?
I think what could be nice to mention is for our V807, so the robotic coping machine, which we mentioned before. That machine is actually able to produce full weld preparations on the top or on the back of a profile. So you can imagine that it's quite difficult to position the torch in the right way to create a bevel cut between the flanges of a profile because of the chance of a collision.
Mm-hmm.
But we have some software which is created by Voortman, and we are now actually able to position that torch in the right way to create high quality weld preparations in the complete front or back of a profile, which can be nice if you have a big plate which has to be welded to that profile, of course.
Mm-hmm.
And what I can also imagine that there's someone's watching this webinar and he thinks like, I have only a small portion of weld preparations which I have to apply to a profile, and you're not going to invest in a robotic cutting machine in that occasion.
Mm-hmm.
But then on our drilling lines we also offer the different milling packages. And one of those packages is the package where you can apply weld preparations using milling. So we have the right tools and the right software, of course, which you can use on our drilling lines to produce and apply the weld preparations on profiles if it's only a small portion of your production.
Yeah, that makes sense. Timo, do you have something in mind?
Yes, what we are going to do from Hypertherm is we are going together with our partners like Voortman to specific end users to try to identify bottlenecks, right? You mentioned bottlenecks, and you would like to have to reduce costs to increase profitability, flexibility, and all stuff like that. And for example, when customers are using a track burner for cutting bevels, like how to make sure that he understand that also bevel is an option for him to reduce cost and stuff like that. And so we try to go to end users together with our partner, as I mentioned already, to show them also opportunities, how to be more flexible and more profitability, and then to be increase the productivity. This is what I would like to say.
Yeah. Joey, you're back. Can you share another topic that might be relevant?
Yeah, so I think what is nice to mention is now we talked several times already about the Müller oplader range. I think one nice feature I saw within their range, and I think that's also nice to mention, is that they have a solution for processing pressure vessels, large pipes, as well as domes. And what they do within that solution is they have a rotator that they use, of course, for the large pipes, but they can also flip it down and use it for domes as well. So they have quite a flexible solution on really a small footprint, and I think that's quite unique and quite nice to mention.
Yeah. So it offers increased flexibility for them.
Yes, yeah.
Okay. It's almost time to answer your questions, or at least some of your questions. So now is the time to write down your final question, while we're going to watch a nice video showing off the Voortman machines and their bevel capabilities, and we'll get back to you in a minute. Let's have a look at the questions which appeared on the screen. The first one is, on my cutting machine from Voortman from 2015, I don't have this extended bevel technology yet. What was shown in the production? Am I able to update and get this functionality?
I can answer this question. For all the machines we offer upgrades, so it is possible for all the machines to have any upgrades on the machine itself, but also for the software. So the best thing to do is, I think, for the one who is asking this question, to contact our after sales department, and then we can find out what's possible with the machine this is about. And also, if you have any questions about programming or something, or about bevel cutting on all the machines, it's always possible to contact our after sales department, and we will help you out.
Yeah. Okay, the next question is, what parts do you believe require stitching to maintain the quality of the bevel? Are there any guidelines or rules for determining this?
I think I can answer the question. I guess it's not necessarily a recommendation about how to stitch, because I even say less is more, and it's also depend on what you cut, which profile you cut, and also which geometry you have, right? And the only guideline I can share is we have multiple difference of stitching. For example, when you cut smaller plates from 3 millimeters to, let's say, 10 or 15 millimeters, we use a stitch, right? A small bridge. I don't know, it depends on the length and on the width. But for thicker material, from 50 millimeters up to 25 or something, we can call it interlocks. You can also cut it as you like, right? But for example, a small T, and you just have to tilt into the curve value. So when you have a thick material and long material, you have just to tilt a little bit on 0 point something millimeter or stuff like that. So you have to avoid that you have a big warping or a tilting of the plate.
Yeah. Another question is, you are pushing quite a lot to beveling on your cutting machines. Do you feel there are reasons when you should not want to apply the bevel directly on the cutting system?
Yeah, I think I can answer that one. Sometimes we see at customers indeed that beveling directly on the cutting machine is not always the best option. And indeed we try to push for it because we have solutions, of course, with automatic beveling options. But what we sometimes see, of course, is even though corner loops perhaps can be prevented in the near future, of course with beveling you get additional waste with the material, especially because you have an angle cut that is crossing the part itself, so you need a larger part spacing. I think what's also important to mention, and we saw that a customer as well also a couple of weeks ago, is that sometimes parts can also be cut with several Oxy-fuel torches at once. So you just have several of the same parts, and from an economic perspective, it would be then logical to cut those parts with multi-Oxy-fuel and then bevel them afterwards on a separate beveling solution.
Okay, next question is, what is the impact of beveling on consumable wear?
Oh, this is a fantastic question. Let me answer to that. When I understand the question correctly, there are two types of, or let me split that in two sections, because beveling has a huge impact of consumable wear. Because in the end, when you consider, or when you have a consumable worn down, for example, or a big waste, the torch is going even closer to the table, so that has also an impact of the dimensions of the cut itself. But the second one is in case of if the worn or the waste of the consumable have an impact, for example, of the lifetime of the consumables, then I can say also yes, because you have a 20 millimeter cut, for example, then you have to tilt the torch. The thickness is much higher, so you stretch the arc, and you get also more heat and more energy into the cut itself. So necessarily, yes, the consumable also, the lifetime of the consumable reduce, not significant, but a bit, definitely.
Yeah, so in the first approach you said the impact of consumable wear on bevel quality,
Yep.
and then the second one you approach it from was the impact of beveling on the consumable wear. Yeah,
Yes.
of course, yeah.
One of the last questions is, when cutting bevels with a Voortman machine and Hypertherm true bevel, what tolerances can I expect?
I can pick that one up because I already explained a bit at our parts production. Yeah, that depends, of course, if you maintain your deck well enough, and if you at least reduce warping of parts. That is important to reduce also those tolerances. But we feel that a bevel, and then especially if you look at the nose, I think that's quite an important dimension. You could receive tolerances of plus minus roughly a half a millimeter. And it really depends, again, like I said, if you maintain your deck good enough and that your plates stay steady.
Yeah.
Because those kind of things cannot always be corrected for.
No.
So
Yes.
that defines those tolerances. And I think what is also important to mention is that in general, for cutting, we always refer to the ISO 9013 for cutting tolerances. And those can also be applied on bevel tolerances as well.
Okay, guys, I think we need to wrap it up. That brings us to the end of this webinar. We can understand that this webinar includes a lot of terminology which you might wish to review later. So no worries, you can watch the webinar back at any time by using the same link you used for this live webinar. I want to thank you all for joining, and thank you speakers for participating as well. If you want to see other relevant articles or customer testimonials or our previous webinars, you can click the button which appears on your screen right now. And if you have any other questions, also feel free to ask them, get in touch with us, and we are more than happy to answer them. Yeah, thank you for watching, and see you next time.